Namaste. On behalf of my school, GK Gurukul, CSpathshala, TCS, PICT, and everyone else who is involved in this great event, I welcome each and every one of you for the second day of the 7th conference on computational thinking. As we gather here, we are reminded of the profound impact that computational thinking has on education. Over the past few years, we have seen significant shift towards integrating computational thinking into schools, into the curriculum, and it is exciting to see the progress that we have already made, and we are quite far yet. We have to do a lot in the schools. Yesterday, if all those who have been here, we had the pleasure of being inspired by Ms. Jane White. It's wonderful. It was a wonderful online presentation. She set the ball rolling by providing valuable insights into how AI can be leveraged as a powerful tool to teach any subject, opening up new possibilities of innovative learning experiences. We also had 5 other presentations which were simple but unique. These presentations showed us the power of experiential learning. This approach not only deepens understanding but also fosters a love for learning that extends beyond the classroom. As we move forward, we can ponder over some points. First, computational thinking is essential for the future workforce. As technology continues to evolve, it's crucial that our students develop the skills to think computationally and solve complex problems. Interdisciplinary approach is the key to success. Computational thinking isn't just about coding, it's about applying the computational concepts to the real world problems in various subjects, from science to maths to languages to art to social studies, etc., etc. Equity and access is also very critical. We need to ensure that all students, regardless of their backgrounds or the socio-economic status, have access to computational thinking, education, and opportunities to develop these skills. As we explore the latest research, best practices, and innovative approaches in computational thinking education, let's keep in mind the ultimate goal is to empower our students with the skills, confidence, and creativity to succeed in this increasingly complex and technological world. Not taking much of your time, I would like to further invite our program committee co-chair over here, Ms. Lakshmi Gandhi. Please welcome Ms. Lakshmi Gandhi to further. Thank you so much.
Good morning, everyone. Good morning. I hope you all had a restful night and ready for another exciting day. So, thank you, Mayuri, for simplifying my job. I think I'll straight away jump into, what needs to be done today. So, before I move into the today's session, I would like to take a moment to highlight the incredible reach that this year's conference has. So we received, next slide please. Yeah, we received an overwhelming 490 abstracts, of which 82 have made it to the conference in the form of presentations, demos, and poster displays. And and they all come from 16 states of India. And a big thanks and a big round of applause for all those who have contributed towards, these many papers and presentations. Next slide, please. So let's quickly take a recap of the highlights from day one. So we had an inauguration and opening remarks by Vipul Shah and PC co-chair Chitra Babu yesterday. And we had marvelous teacher presentations on various topics, including the physical computing, CT, and coding. And we had an insightful keynote by Jane Waite, a senior research scientist at the Raspberry Pi Computing Education Research Center. And she touched upon basically three themes. Uh, how to enhance teacher productivity using AI, and how do we teach AI to the students, and how do we use AI in various subjects. These were the three sub themes that she had touched upon. And we had amazing and very innovative and engaging poster and demo sessions by the teachers on the first floor of this complex. Next slide, please. And then moving on to the today's highlights. So we have a very interesting day planned for you all. I hope you're ready for the excitement and insights that presenters and the panelists are going to present to us. And towards the end of the day, we are also going to have some posters and presentations by the Vision Empower. And next slide, please. So we are forever grateful to all the sponsors and the regional conference partners for making this conference possible. Have a wonderful and an exciting day. Thank you. Now I call upon Manisha to go ahead with the proceedings.
Good morning, everyone. How are you? Yeah. So teachers are ready with their best practices approach in their classroom. And I invite the first group. This session includes the city integration in coding, physical computing, and city for professional development of the teachers. So first group is from Meghe Group of Institutes. Ankita Zhalke and Shalini Sahare, they are presenting on e-file statement in Scratch coding.
Good morning, everyone. First of all, I would like to say thanks to everyone for giving this wonderful opportunity to present ourselves in front of you. So, my name is Ankita Jalke, and she is my colleague Shalini Sahare from Mahatma Gandhi English Medium High School, Nagpur. Today, we are going to present presentation over the topic e-file statement in Scratch using CT. Ma'am, next one. Now let's go towards the implementation. To introduce e-files concept, teacher began with a real-life analogies, such as deciding whether to wear a raincoat based on the weather. And next one is, if students have school tomorrow, the sprite will say, wake up at 6 a.m. Else, the sprite will say, enjoy your holiday. This helps students to relate conditional logic to everyday situation. Students were guided through creating a simple games where a character responds differently based on the player input. Next. Okay. This project has been created by our students in which create the simple calculator with the help of Scratch. Next. Create the game of rock, scissors, paper by using Scratch. Next one.
The next project which has been created by our student is find the greatest number among three numbers with the help of Scratch, in which they have used nested if else statement.
Now, CT skill which have been used for stone paper scissor games are: first one is algorithm design. A step-by-step process is created to handle the game flow. When the player click a choice, the input store in a variable. The computer generates a random choice between stone, paper, and scissor. Then choice are compared using if-else block. Decide the winner. Then result win, lose or draw is shown the players by using say block. The next one is conditionals in where we use decision making blocks if and if else to control the flow based on user input or conditions. The next one is decomposition, in which the game is broken into smaller and manageable parts. The players gives an input by selecting the stone, paper, or scissor. Then the computer makes a random choice using a random number generator. Then the program compares the players and computer's choice. Based on the comparison, the game decide and display who won.
Now next, abstraction, where only the main parts like choice and result are considered while coding. Each choice can be represented by a number of word like 1 is equal to stone. Extra visuals and animations are hidden during testing to keep the logic simple. Now next, pattern recognition. The game flows fixed result that repeat every round. Stone always beats scissors as per the rule. Scissors always beats paper in the pattern. Paper always beats stone according to the logic. The same comparison logic is reused in every round of the game. Next.
As you can see, these all are the live pictures of students. Now they are performing different practicals with the help of different logics.
Okay. We have faced all the challenges during the practical session. Students initially struggle with understanding the structure of conditional logic, especially when if-else statement. To overcome these, we use visual flowcharts alongside scratch blocks to simplify the concept. Another challenge was maintaining consistent participation, which was addressed by introducing collaborative group activities. Difficulty to grasp the concept of if-else or cause-effect logic. Trouble predicting how the sequence of block will affect the behavior of sprite. Spending too much time decorating or animating without completing the logical part of the project. Next.
Now those all are the impacts. As you can see, implementing if-else statement in Scratch significantly improves students' ability to think logically and develop interactive projects. Students reported a sense of accomplishment when they saw their ideas take shape in the form of working programs. Through regular assessment and peer reviews, teachers observed that students were able to break down the problems in logically and implemented solution efficiently. Additionally, classroom discussion reveals increased confidence in coding tasks, the students expressing enthusiasm for experimenting with more complex conditions.
Next. Conclusion. Teaching the if-else statement using Scratch proved beneficial in developing logical thinking skill among students. The use of visual programming made abstract concept easier to grasp and encourage creativity. Moving forward, incorporating more interactive scenarios will further enhance student computational abilities.
Thank you.
Thank you. It was a wonderful presentation, and you have done gamification coding, and I know that Scratch is very engaging the software. So, are there any questions for the presenter?
How much time you require to complete this activity or project?
Minimum 2 periods. Minimum 2 periods.
And what was the age group?
Age group means third and fourth standard.
Thank you.
Thank you, ma'am. Then
Thank you. We will move to the next presenters. This is about the city in professional development of the teachers. Miss Kritika Krishnamurthy and Dr. R. Ramanujam. So they are presenting city curriculum implementation in India, a sliding ladder.
Good morning, everybody. I would like to thank Tamil Nadu SCRT CTIS 2025 people behind for giving me this opportunity to. Are you able to hear me now? No? Are you able to hear me now? Yeah. So first of all, I would like to thank Tamil Nadu SCRT CTIS 2025 and the entire team behind for giving me this opportunity to present this paper, and also my co-author Jam. So this is based on the experience from Tamil Nadu. So where we have integrated computational thinking in math curriculum. So yeah, next slide, please. So we have revamped the Tamil Nadu curricular framework in 2017, and then new syllabi was rolled out in 2018. Especially in math, we have replaced data handling chapter with information processing, where we had the opportunity to integrate computational thinking concepts. So the weightage of it is 20% of the weightage is for CT, means for the information processing unit. And the reach is 30,000 schools, 2 million students were using it, and these were taught by 80,000 teachers, government teachers, yeah. So the curriculum was framed based on the CSpathshala curriculum. Yeah, could you please move on to the next slide? Yeah, so these are the sample screenshots among, though we have given lot of activities. I would like to show a couple of activities from that. One is the tetrominos. As you can see, we have asked them to compare with the children, compare with their peers, how they are doing and what is the difference, what are the similarities, arrangements, all these things. We have given the options in it. Next slide, please. And this is one more activity of giving instructions. So the teacher will give instructions on some geometrical figure and the students has to follow it and draw it. And yeah, could you please move on to the next one? Yeah. So having said that, we have set the curriculum and syllabi is ready and textbooks are ready and the activities are there in the hands of the teachers. Now, we'll talk about how the teacher's perception and beliefs and all these things are in the reality. So a teacher was asked, like, she's from Attipalayam, which is a rural area in Tamil Nadu, and she teaches for classes 6 and 7. And what about the classroom scenario? Students are enjoying it very much. So this curriculum, I mean, like the CT activities are very much easy for the students. And the teacher herself is doing something different, so she's also enjoying it, which is also more important. So yeah, so when asked, do you teach computational thinking in your classroom? Then they said, no, ours is a rural school. We don't have computers. So we don't do any of these CT. So do you teach data organization? We do have data handling chapters, and we taught pie charts, bar graphs, and all these things. Those were in the earlier thing, not now. So yeah, could you please move on to the next one? So what's the difference now? So we have got all these in the textbook, activities are there, but the classroom scenario is this and the teacher is feeling this. So what's the curriculum implementation then? So educationists have said that there is always a difference between the curricular objectives and the how it is getting implemented in the classroom textbooks and how it is going into the classroom. So there is a difference. So as over the years, this will get drift away from what is the objective. So yeah, the other thing is that sustaining the belief system of the teacher, that it is really useful and how it is related to the objective set in the curricular framework. So already we do know that there is a complexity in the existing curriculum. Now CT is the additional for it, right? So yeah, these are the things that is from the real practical situation. So yeah, could you please move on to the next one? So yeah, we had the opportunity to, means TNSCRT has organized the workshop for the teachers. So these are the experienced teachers who has nearly 10 plus years of experience in teaching. So we have conducted the workshop on CT. We had the opportunity for conducting activities for the teachers, though we didn't give the activities exactly in the textbooks, but similar to that, we have given some activities. Yeah, thanks. Next one. So the response of the teachers. So these were the observations made from the workshop. So they were positive about the lessons. Oh, lessons are so nice. We are enjoying it. It seems to be so interesting. But they couldn't see the computational thinking components. So because for them, computation is always related to computers. So then we didn't see any connection between earlier data handling chapters with the information processing where we have integrated computational thinking. They couldn't see the connection between these two. And they couldn't see activities in our sessions as the extension of their textbook. For example, in earlier slide, we have shown that teacher giving the instructions, right, for the geometric thing. But the similar activities like drawing column we have used. But they couldn't connect this drawing column is related to following instructions. So these are the things that we could observe. So the thing is that they didn't see new lesson and activities as the possible assessment items. So yeah, next slide please. So we were able to see, oh, yeah, new and interesting city activities to classroom. There is much greater potential and scope for doing this. And the teacher believes an understanding of curricular goals is something that we need to think about it. We don't see any impact or the little impact in it. So CT remains in the margin of mathematics education. So observations such as these need to be checked against the rigorous policy or rigorous research based on this. So all that we need is a lot of resources and research in this area. Thank you.
Thank you, Kritika. It was really impressive presentation, and we can see how much efforts they have put up to get such a huge reach. So I think you have some questions for Kritika. Yes.
Could you please elaborate your question?
And understanding of why this curriculum has been designed, why data handling is replaced by information. So, how did you fix the gap?
So the thing is that this is just the workshop. So the thing is, we took this opportunity to take it to the teachers because after the curricular revamp, we have got the pandemic. So because of the pandemic, we couldn't reach for the entire teacher level. So we thought that this will be the nice opportunity for us. So during the workshop itself, we used to connect what is the curricular framework and what is the objective and all these things. We have shared the curricular framework to the teachers who have attended the workshop and ask them to share their views on it. And also there, and while conducting the workshop itself, we used to connect that these are mentioned. This is what the educational perspective is. This is what the CT's perspective is. So yeah, these are the things that we could do as much as we could in a couple of days of workshop. Thank you.
Very clear. So, thank you. Now the next presentation will be online, and it is from Mr. Jinu John from JBCN International School, Chembur. He is talking about the art of debugging.
there was conducted mainly with the grade 7 students who were just learned about Excel and were developing more skills in Excel. So it started with very simple, that is your spreadsheet. But what unfolded was a very powerful lesson in logic debugging. I always believe that education is not just about solving problems, it's about how we approach them. And one day it just struck me that debugging is not just about fixing code, it's about looking at errors without fearing, finding patterns, asking questions. And that exactly was something what I wanted my students to learn, because in these curriculum we always teach the students how to solve a problem. We never go through such kind of scenarios where if our student is stuck with some kind of problem, how they are able to come out. So that is when this insisted on having this kind of coding lessons where we could use debugging to reflect on their thinking, their level of understanding and approach. What if we taught them to debug life, to pause, notice and rethink? All this struck. So this was my main objective of having debugging. So integrating it into the complete and writing down algorithms. So this was keenly for the grade 7 students. As I had mentioned, I designed an Excel activity that mirrored different kinds of real world sales and inventory sheets. I had different kinds of scenarios for different groups. It was based on, some activity was based on bakery, simple enough so that they could relate, but detailed enough to make them think. But here was a twist which I brought in, where I deliberately added some kind of errors, some formulas pointing it to the wrong cells, some stocks were negative, the discount logic was broken, and then I handed it over to the students. Not to learn Excel, but also to understand the joy of figuring things out. Their goal was to find the bugs, fix them, and make sense of the mess, because now they had the basic understanding of Excel, they had the basic understanding of the approach. Now, how will they solve them when they got stuck? So that was all about what I was looking forward to. So we started with different kinds. We began with the observation, where I told them, don't fix anything, just look, think, talk, and try to reach out with each other. Okay, and that's where actually the magic started. Students began noticing, why is stock negative, or why is the discount showing some kind of text. Then they moved on to different kinds of formulas of debugging, where they corrected the revenue calculation, tried to find out the fixing of the if statement, and finally formatting, making the sheets readable and meaningful. So that is when I saw that students were not just improving with the Excel skills, but they were growing confident. They weren't afraid of mistakes anymore. They were talking about analysts. This is not just about Excel. In fact, you can bring about purposeful mistakes in your teaching as well. Like when you're teaching this learners, you purposely make a mistake to see whether the student is listening to you, paying attention to you. So that is a different way of approaching them altogether. So this not only shows you that yes, students are understanding, but also to make them feel that mistake is fine, it's okay. How to go ahead and how to improve on it is something which we are looking forward to. So, as I had mentioned, this was how the grade 7 worked, with the errors and trying to identify correct errors. So, in fact, I brought initially also, I had mentioned to them while I was teaching that there are different kinds of errors which comes in Excel, where you divide by 0, you find something not applicable. So, these were some errors which were shown also to them, so that they know that yes, these kind of mistakes can occur. What is the kind of approach we need to have so that we are able to build upon. So, further, if I set all the implementations as I've already mentioned, this led to a student led discovery. They worked with different kinds of debugging formulas. They went on improving their formatting, coming up to the number formats. And not only that, because this is somewhere where I'm not teaching. It's all about how students are forming group, working together, sharing the strategy. Some are coming up, why don't we follow this? Or having there some kind of a distant map where they could know that what kind of possible errors could occur. So further, we try to emboss. So if you look over here, how did the students work on? They broke down the different spreadsheet, tried to find the pattern, then focusing on the relevant data and ignoring, and then having this kind of step-by-step approach. So this way it helped each other. So the final was like a kind of formative which I conducted, like a 30-minute challenge, where I gave them multiple kind of errors they could find within the time limit. So this gives them a constraint of how to work within the stipulated period of time. So there was complete quiet, filled the room as teams were all racing to solve how many bugs they could solve. It actually didn't feel like a test. It was like a complete good team sport. So yes, I definitely faced different kinds of challenges where students were confused with complex formulas. They were, afraid how they will work on the mistakes. But definitely over the period of time, it was difficult to, ensure that all the students are engaged regardless of any kind of level. So it played an important role for me when I was trying to work with this kind of challenge. But yes, further, if you see, like after hearing itself, you must have realized that the impact was beyond of what I had imagined. They were so excited when they were able to fix the formula, and the whole sheet was making sense, and had a different way of practicing Excel apart from that kind of boring we find Excel. So it's like for them like a solving a crime scene. So they were asking each other which cell you're referring to, or is it you're using if condition, what can you do if you want to use something else. There are different kinds of variations or conditional formatting. So from being intimidated to the Excel, they became curious and quite confident. What stayed with me most were how they were enjoying the mistakes. So that was our main objective, and treating them not as a failure but as clues. So this is something. So if you see, they have completely worked on computational thinking, has completely come alive, where they broke the problems into parts, that was decomposition, spotting the recurring issues, that was pattern recognition, learning to ignore the noise and focus on relevant logic was abstraction, and finally working on the logical steps to fix, that is your algorithmic thinking. So all these kind of, we didn't have to focus on these terms, but it happened naturally, not through theory, but all through what hands-on activity we can see. So last, let's go what the students were like. They were very excited to find the conditional formatting, how they could solve the different kinds of errors, how they helped use this debugging in solving the real life problems. They came up with a lot of experience trying to say that yes, this was something very understood. Even one impactful story was student even used it in math, where they were finding mistakes there, trying to solve, and had improved grades. So as a teacher, this kind of little spark was everything for me. So if you look over here, definitely there were a lot of hurdles, a lot of overwhelmed students were initially, others just following. But the moment we step back and let them struggle a little and talk a little, explore more, like just we, it's like if you send somebody in a den or something, they will try to find a way or a path to come out. It's like that. That is a real learning which has happened over here. So as a teacher, if you ask me what is my biggest takeaway, is give students different kinds of messy problem. Let them think aloud, let them debug, not just to fix but to discover. So this is all the taught activity which taught me that they need to think, the tools to observe, and a kind of trust which they can figure out on how they can do. Okay, so finally, to close up, I want to say what I started as a simple activity of Excel became a journey for them to think, reflect, and have fun. So grade 7 has now approached the mistakes differently. They were able to question better. So working with these kind of simulations in real life and real time, taking more scenarios is definitely going to help them. So thank you for giving me this space to share. I hope this small activities has inspired you as much as it inspired me during my classroom session.
It was wonderful approach. How a teacher can take one concept and yeah. So how one concept can integrate all the city element, and it comes in the real life also. So it was wonderful presentation. Now the time for appreciation. I call upon stage Shalini ma'am and Ankita and Kritika ma'am for the certificates.
हम बीच में परम के सामने जाके ले लेना या पीछे नहीं कुछ नहीं बचा
Yesterday, you witnessed the innovative ideas in the form of poster presentations. I would like to call upon all the poster presenters here. Please come on the stage. Everybody enjoyed your hands-on approach and it was really wonderful. Please come. Okay. For posters, do you have any questions? Any question for the poster presenters? Because I know yesterday you would not be able to talk to them. If you have any query, you can ask. Yeah, this is the team of poster presenters. Please give them round of applause. Yeah, it's a wonderful work. Come, come, come. Take the photo. Okay. Is there any experience sharing for about the poster presentation from presenter's point of view or audience point of view? Anything you want to say?
Actually, the poster present. Good morning, everybody. I'm Swati Ranade, and I presented my poster for the first time in the conference. However, I had given presentations earlier, but this time it was a completely new experience to present a poster, like a demo session. In the demo session, we could present our ideas and we could explain why we did what we did in the form of activity. So actually, when everybody came and they actually had the activity like children, the joy on their face was also like children. Like when they got the thing or they could solve it, the joy on their face was actually so. So the child in us is still alive, and we should keep it alive. Thank you.
Thank you all. You can collect your certificates from the registration desk. And thanks a lot. It was really wonderful to see all the posters and all. So, congratulations to all of you. Yeah. Please give them round of applause.